Alright, so tonight what we want to talk about are linear factors. And when we're talking about polynomials, what do we mean when we say linear factors? We'll go back to the quadratics unit. Just remember, quadratics are polynomials. So all of the rules and everything that we did during the quadratics unit still applies to the polynomials unit, because quadratics are just a type of polynomial. And so when we had a quadratic like this, we learned in the quadratics unit that we could factor this, and then we could use those factors to then solve the equation. If this was x squared plus 4x minus 12 is equal to 0, we could factor this. And we learned that what we were looking for, since there's no number up front, we're just trying to find two numbers that multiply to equal negative 12, add to equal 4. So something like 12 negative 1, 6 times negative 2, 4 times negative 3. I think that's all the numbers that multiply to equal 12. And which of those pairs adds to equal 4? The second one does. So that means that if we were to factor this, it's going to be x plus 6 times x minus 2. And then if you remember from the quadratics unit, once we had factored it, then we could take and we could set those factors equal to 0. What I do want to point out is that this is what we are referring to when we talk about a linear factor. I took this quadratic, it was x squared, but I broke it down into two expressions that are linear. It's just x to the first power. So this is the linear factors of that particular polynomial. Having it in factored form is key for all polynomials, because when you have it in factored form, you then can solve it, because we can say x plus 6 is equal to 0 and x minus 2 is equal to 0, and then when we subtract 6 from both sides, I get that x is equal to negative 6, and when I add 2 to both sides, I get that x is equal to positive 2. This was one of our methods for solving quadratics, and that's where we came up with the fact that factors and solutions do in fact refer to the same thing. In fact, we said that there were 5 words that actually all were referring to the same numbers. Factors were meaning the same thing as roots. Root is just another word for it. A lot of times they'll word questions. Find all the real roots. What do they mean by that? Well, you just have to remember, roots are the zeros, are the solutions, are the x-intercepts. Zeros, we said we always wanted to remember that one because zeros is what it's referred to on our calculator. If you go to the second trace menu, 0, that's your option on the calculator. It's also a reminder that when we go to look at the table, we are looking for a 0 in the y column. We want it to be equal to 0. These are the solutions. It's kind of the point. If we know that when we factor it, we are getting the solutions, and the solutions also are the x-intercepts. So again, you can use your calculator. Find those x-intercepts. They are the solutions. One important thing to note is that roots, zeros, solutions, and x-intercept are all the exact same numbers. They're the same numbers. The factor is related to it, but this is referring to linear factors. So that means that it's in the form x plus 6 and x minus 2. It's not equal to just a single number. It is actually a linear factor. And notice the relationship here. When the solution was negative 6, or the x-intercept is negative 6, the 0 is negative 6, the linear factor actually turned out to be x plus 6. And it's because this is what the factor was when it was equal to 0. That's what we solved to get negative 6. So it is important to note that these linear factors are always going to be the opposite of whatever the x-intercept or the solution. If I have one that has an x-intercept of negative 5, then my linear factor is going to be x plus 5. If I have something that has a 0 of 3, then its linear factor is going to be x minus 3. It's the exact same number, just the opposite sign. We're putting it in a linear factor. So this is not just a single number. It is a linear factor, something along the lines of x minus whatever the 0 is, because we want it to be the opposite sign. Okay? How is that useful to us? Again, we want to always associate these terms with each other because it helps us to find things we don't know what they are. So when we, let's say we wanted to factor this particular polynomial. All right? So if I wanted to factor this, the problem is it has 4 terms. None of the rules that we learned with quadratics last time helped us when we had 4 terms. And so I would kind of be stuck trying to factor this one. But if I remember that the linear factors are also the zeros, I then have a thought. Well, what if I were to go in my calculator and see if I could find these zeros? Let me see if I could find these x-intercepts. So I'm going to go to y equals, and I'm going to type in the equation. X to the third, don't forget, use your little caret top when you're trying to do some of these larger powers. X to the third plus 6x squared plus 11x plus 6. And if I go to my table, I want to see if I can find some of these zeros. Oh, look at that. They lined up for me. Even better. I have in my y column 3 zeros. Now, we'll give you a hint, a little jump ahead in the unit. Your degree, your highest power, tells you how many zeros you should be looking for. And I happen to find 1, 2, 3. Fantastic. That means that for this particular polynomial, my zeros are -3, -2, and -1. Well, if those are my zeros, I remember the zeros always end up being opposite of the linear factor. So that means that my linear factors must have been x plus 3, x plus 2, and x plus 1. I just factored that polynomial with my calculator. Blew your mind. It's very important to remember that these are all referring to the same thing. Now, it's a lovely idea to think that we can now factor every polynomial by just using our calculator. But we know that that is not the case. There are some limitations to that. For one thing, I knew this one was going to work out because I planned it that way, but also because there was no coefficient up front. One of the things that messes up our zeros is when there is a coefficient up front. Usually that means that there is a fraction involved as one of our zeros, and so these turn out to be not even numbers, which, as you know, the calculator doesn't actually find as well, and so it doesn't always turn out to be nice and neat and easy. However, whenever I do have a coefficient of 1 here, I do try to use my calculator to help the process go a little bit quicker. Let's say we have one that doesn't. Well, that's why we learned all of these factoring techniques last unit. We're going to learn a couple more factoring techniques during this unit as well. One thing that we always want to look for first is a GCF. And if you've forgotten what that stands for, it is the greatest common factor. All right? When we look at a problem, in this particular one, the first thing that jumps out at me is that it has x in common. So I can factor out an x. I also notice that 6, 39, and 21 are all divisible by 3. You must always look for a common factor first, folks. All our other factoring techniques don't work if we don't pull out the greatest common factor first. So the first thing I want to do is pull out the common factor. So 6x cubed divided by 3x is going to leave us with 2x squared. -39 divided by 3 is -13, and x squared divided by x is just x. And then -21 divided by 3 is -7, and then the x's cancel out. So this will factor. Now I can look and see, okay, let me see if I can factor here. I'm going to do my headphones. 2 times -7 is -14. I need a pair of numbers that multiplies to equal -14, adds to equal -13. -14 and 1, -7 and 2, I think are my only two options, and it looks like the first one is the one that works. Now remember, when there's a number up front, we do actually need to go back to our box to help us figure out what this was originally. We want linear factors. This is quadratic, so we're still looking for linear factors. So if I use that -14 and 1, this was 2x squared, -14x, 1x, and what was this up here? -7. So what do these two have in common? A 2 and an x. The only thing these two have in common is 1. These two have an x in common, and this first one's negative, so this is going to be negative, and it looks like they have 7 in common, so -7. So that means that this ended up factoring to be 3x times, we've got 2x plus 1, and x minus 7. Notice, 1, 2, 3 linear factors. They're all x to the first power, 3 linear factors, for x cubed. Another way this is useful, I'm going to give you some insight into how teachers make problems that actually work out to work. You can be given the zeros and then asked to find the polynomial that goes with them. Well, again, if I know that these are the zeros, then I know that they can be made into linear factors, just like we did over here when we were trying to factor this one. Once we knew what the zeros were, we were able to translate those into linear factors. So that's what I can do over here. If I know that these are my zeros, these are the zeros, then I know that they can also be written as linear factors. So let's write them as linear factors. If it was positive 2, that means the linear factor must have been x minus 2. If it was negative 3, the linear factor must have been x plus 3. And if it was positive 4, the linear factor must have been x minus 4. The thing is, this is linear factors, and it's written in factored form. They wanted us to write the polynomial in standard form, which does mean that we need to multiply these out. Now, there's not some way where we can multiply all three of them at the same time. That would be spectacular, but there's not. So that means that we do need to just take two at a time, multiply them, get the answer, get the product, and then multiply it by the third one. So I'm going to FOIL. That's going to give me x squared. Let's see, positive 3x and negative 2x is positive 1x. And then negative 2 times 3 is negative 6. So these multiplied to be this trinomial, and now I need to multiply it by x minus 4. This is where I tend to err on the side of caution. I do use the box method just to make sure I don't forget to distribute something. So x squared plus x minus 6 and x minus 4. So that's going to give me x cubed, x squared, negative 6x, negative 4x squared, negative 4x, and negative times negative is actually positive 24. I look for some like terms. I do have a couple of like terms here. So when all is said and done, if I'm going to write a function, so f of x is equal to, and a polynomial in standard form, it looks like my standard form is going to be x cubed. Negative 4 and 1 is negative 3x squared. Negative 4 and negative 6 is negative 10x plus 24. So this would be my polynomial. Now, if I was looking to check my answer, don't forget our good old friend and the fact that, again, factors, zeros, roots. Let's see if this actually did work. Y equals, it was x to the third power minus 3x squared minus 10x plus 24. Let's look at that table again and see if the zeros turned out to be right. Negative 3, 2, and 4. Our zeros are in all the right places. So that means that we did do this correctly.